for the substitution method. So first, you need to pick a variable that you want to solve for and an equation. Okay. Once you have decided to what variable you want to solve for in the equation, then solve for that variable. After that, the resulting equation, plug it into the equation that you didn't use, solve the linear equation that you have, and once you get the value, then you plug it into the other equation to be able to find the other variable. Okay? So here there are 3 examples. Let's solve them. So what I'm going to do is, we're going to do this together, we're going to do the other method together, and then I'm going to give you some problems for you to try on your own. Okay? All right. And also we have to see, how do we spot here situations in which there is a solution when there is no solution? I mean, there is a solution, it's easy. You solve it and you find a solution, then that's it. But how do you decide whether there is no solution or not in this approach? Okay? If you don't want to look at slopes and so on. Okay. So let's solve this. So solution. So for the first one, we have ax minus 16y equals 3, and then y equals 1/2 x plus 1. So in this case, this is really begging you to use substitution method, because here basically we already have one equation in which one of the variables already solved for. Okay? So let's see, what variable do you think we should replace in here? Y, because we already know by looking at the second equation that y equals this expression, right? So what we're going to do is we're going to take this and we're going to put it in here. Okay? And then we only have x's. So I'm going to call this equation 1, and this one is equation number 2. So what I'm going to do is I'm going to plug equation number 2 into equation number 1. Okay? So we're going to obtain the following: ax minus 16. Now instead of y, I'm going to write what I have in there, which is 1/2 x plus 1 equals to 3. Do you understand this? We already know what y is equal to. Okay, so all we have to do is replace it in the first equation. Questions on this? Now this is a linear equation, only one variable, x. We know how to solve this, so let's solve it. So let's first distribute the parentheses. So when I multiply by 16, what do we get? Who can tell me? So negative 8x. What else? Minus 16 equals 3. Right? Just negative 16 times 1/2, the 2 cancel with the 16, so you get 8, so negative 8. And then negative 16 times 1, that's negative 16. Now here we see that something interesting happens. When we simplify, notice that ax cancel out, and we get the statement negative 16 equals 3. Now this right here is something that's always false. Okay? So what does that mean? It means that this is impossible to happen. Whenever you use this method and something like this show up, something that doesn't make sense, that is false, what this is telling me is that the system has no solution. This is a case in which the lines are parallel. For example, let's write the slope-intercept form to see it. So let me finish here. So when this happens, okay, this means that there is no solution. Okay, so the system is inconsistent. Okay, and then let's look at equation number 1. So indeed, equation number 1 is ax minus 16y equals 3. Let's write in a slope-intercept form. So that will be negative 16y equals negative ax plus 3. Let's divide by negative 16. So what do we get? We get the y equals negative divided by negative is positive, so that's 1/2, 8 over 16, minus 3 over 16. So this is equation number 1 in slope-intercept form. If you look at equation number 1, and if you look at equation number 2, what can you say about the slope of the two lines? What's the slope of this line? The red line? What's the slope here?
1/2.
1/2. What's the slope of equation number 2? same slope. Notice that the y-intercepts are different, right? That one is a +1, this is a -3/16. So the lines are different, but they have the same slope. They are parallel. Therefore, they don't cross. So that's why you see that they have no solution. So we are in this situation. The same slope, so we are in this picture right here. So we are in this case. Okay? The slopes are different, the y-intercepts, the slopes are the same, y-intercepts are different, so we're talking about two lines that are parallel, so no solution. Okay? Again, what I just did, that was just to verify, okay? But when you're solving using substitution method, if you hit something like this, like a number equal to another number, something that doesn't make sense, then this is an indication that there is no solution in the system, okay? And you can verify by looking at the slopes. So let me say here, so slope is 1/2, same as equation 2. So no solution. Because remember, when the slopes are the same, that means that there are no solutions, provided the y-intercepts are different. This last part that I did, this is extra. This is just to verify what was discussed before, okay? The problem finishes right here. You do your substitution, you try to solve, you get something that's always false, that's it, no solution, okay? All right, questions? No? Okay, so let's do the next one. So let's see, number 2, we have 3x plus 6y equals 12, and then 2y equals -x plus 4. Remember, we're trying to solve these equations at the same time. So here we're going to try a substitution. Let's see, what variable would you like to solve for? What variable do you think would be nice to solve for? X. Okay, good. X using what equation? Okay, very good. So we can use equation number 2. Notice that here you may be tempted to divide by 2 to solve for y. But what's going to happen if you divide by 2? It's not a big deal, but what happens if you divide by 2? You're going to get a -1/2 in here. You see that? And then that fraction, you have to deal with that, okay? While here it's easier to just move the x over here, bring this guy over here, and then you don't have fractions and you just plug in nice numbers, okay? But it's up to you which one you want to solve for. So let's go ahead and let's solve for x using equation number 2. So I'm gonna solve for x using equation number 2. Okay, so we have 2y equals -x plus 4. I'm gonna swap, so the x comes to the left positive and the 2y goes negative, so that becomes 4 minus 2y. So just switching these two, okay? Any questions up to here? Okay, what are we supposed to do now? We solve for x. What do we do now?
Plug x into the first equation.
Into equation number 1. So notice that we use equation number 2 to solve for x. So now you're gonna plug it into the other equation. If you plug it into the same equation, everything will cancel. Okay? And you're not gonna get anything. So now we need to plug it into the other equation. We didn't use number 1, so we're gonna use it now. So now we're going to plug x equals 4 minus 2y into equation number 1, okay? All right, so we're gonna have 3, instead of x, I'm gonna put a parenthesis, plus 6y equals 12, and now let's plug in. X is 4 minus 2y. Do you understand this? So you have your expression for x, and that's what I put here. Okay, notice that that's where x is, so instead of x, you put 4 minus 2y. Now we have a linear equation in one variable. We can solve it, so let's do it. So we get here 12 minus 6y plus 6y equals 12. So notice that the 6y's cancel out, and then we get the statement 12 equals to 12. So what's happening here? So this is always true. What do you think this means? What do you think this means? So this is always true. So before, we got something that didn't make sense, that was false, and then the conclusion is, okay, that means there is no solution. The lines are parallel, okay? So what do you think this case is telling us?
We have at least one solution.
At least one solution, but only one or more?
Infinite.
Here we're saying that y can be whatever you want. It doesn't matter, it's gonna be constant anyways, right? So that means that here you're gonna have infinitely many solutions. So you are in the case of the same line. Because now y is free to be whatever you want, x is not free. X has to be 4 minus 2y. But here we're saying that whatever y is gonna work. Now you give me a y, then I will give you the x. Okay? So it's not whatever point you want, but one of the variables is free. In this case it's y because we decided to solve for x. So any point that has the form 4 minus 2y comma y, we solve this equation. Okay? So when this happens, that you get something that's always true, this is the situation of the same line. So this means that we have infinitely many solutions. This is the case of infinitely many solutions. In other words, we have the same line. We're gonna verify it now soon. Now, how do we write the answer? So how do we write the solution set? Because now there is a solution set that is infinitely many. This is what we write. So we're gonna use set builder notation. Remember, these are points. So these are points of the form x comma y, such that, now what's the condition? Y is free and x has to be 4 minus 2y. Such that x equals 4 minus 2y. Okay, this is how you will write the answer. So it's all points that satisfy this form, this equation, okay? So whatever y you give me, the first coordinate has to be 4 minus 2y. This is how you write. Another alternative could be that you can go ahead and in here, when you are in this case, you can put any of the two equations that you have. Because as you can see, what I wrote down there was this, which is the same as equation number 2, okay? But then you could also write equation number 1. Let me show you that the two equations are the same. In here. So equation number 1 is 3x plus 6y equals 12. Even though they don't look the same, you will see that they are the same. Let's solve for y. So what do we get? We get negative 3x plus 12, then dividing by 6. What do we have? We have that y equals negative 1/2 x plus 2. Do you understand this? Yes or no? Yes? Okay. Now let's solve equation number 2. Let's put it in slope intercept form. This one is easier. So we have 2y equals negative x plus 4, dividing by 2. What do we get? What is this? Who can tell me? I'm asking you a very simple question. Negative 1/2 x plus 2. If you look at it, what can we say about these two equations?
They're the same.
They're the same. So we're talking about the same line, infinitely many solutions. Okay? Again, here we're just verifying. So how did we detect this situation? Let's say that you don't do this. How did we know that this was the case? Well, because as you were solving, we came up with this. All the variables are cancelled. When all the variables disappear, two things can happen. You either get something that's always true, like this, or something that's always false. If it's always true, infinitely many solutions, and this is how you write it. Okay? That's the solution set. You use set builder notation, point, such that, and then put your favorite equation. 1 or 2. You put it in here. That's gonna work. Okay? Or if you get something that's always false, it's like the previous example, you just say no solution and walk away. Because that means that your lines are parallel. Do you understand this? All right. Now let's do the next one because So in other words, this is how you spot those cases. So now let's do number 3, which hopefully we'll be able to get some solution out of this. 2x plus 3y equals 7. And then 5x plus 2y equals 12. 2x plus 3y. Okay, so in the previous two examples, it was a little bit easier because it was clear what's variable to solve for, okay? Here, all the variables have coefficients, and both equations, they have the same level of difficulty, okay? But the point here is that it doesn't really matter what variable you're gonna solve for and what equation you're gonna pick, you're gonna end up with fractions and you will have the same level of difficulty, okay? Because there's really no essential difference between equation 1 and equation 2. Do you understand what I'm saying? This one has a 2 and a 3, and this one has a 5 and a 2. Okay? And this one has a 12 here, and this one has a 7. But all variables have numbers in front, and it doesn't happen that everything will cancel. For example, if this would have been a 4 and this would have been an 8, then I would pick this one because if I divide by 2, my x would be alone and no fraction. Okay? So it would be very easy to solve for x. But in this case, no matter what variable you solve for, you will end up with fractions. Okay? So when this happens, just pick whichever you want and whatever equation you want. Okay? So let's begin. These are my equations. Let's see, what variable you want to solve for? Which one do you want? It doesn't matter.
1.
Okay, equation 1, what variable do you want to solve for? Y. Okay, so let's solve for y. So remember, following the steps, let's read the steps so you see how to use this. So you need to pick a variable and an equation. Okay? So the variable that we're picking is y, and the equation that we're picking is equation 1. Okay? Step number 2, solve for the chosen variable using the equation. So I'm going to solve for y using equation 1. So solving for y. You don't have to write this, but I'm writing so when you read these things, you understand what you're reading. Okay? You just do it. So solving for y using equation 1. That's the first thing that I'm going to do. Okay, so equation 1 is 2x plus 3y equals 7. So 3y is negative 2x plus 7 dividing by 3. We get that y is negative 2 over 3x plus 7 over 3. Everybody okay with this? Okay, so we solve for y. Now, what are we supposed to do? Let's go to steps. So we already did step number 2. We solve for y. Now, step number 3, plug the result of step 2. So that equation that we got, plug it into the other equation, right? So the other equation is equation number 2. So now I'm going to plug y equals negative 2 over 3x plus 7 over 3 into equation number 2. All right, so that's 5x plus 2, I'm going to open the parentheses, equals 12. And then inside, I put what I got. So I got negative 2 over 3x plus 7 over 3. Any questions up to here? For example, this is, I guess, as complicated as this method can get, where you will get fractions and you're not going to get anything nice. Typically, you use this method if it would be nice. If it's not going to be nice, then you use the other method, which is the next one that we're going to explain. Okay? All right, so again, pick a variable, pick an equation, solve for that variable. We decided to solve for y using equation 1, then plug that result into the other equation. That's what I just did. I went to the second equation where I see a y, I put the equation that we're obtaining above. Now notice that we have here a linear equation with one variable, just x. So solve for x. So now we solve for x. Okay, so let me clear the parentheses first. So I'm going to distribute the 2. So we're going to get negative 4 over 3x plus 14 over 3 equals 12. So remember, this is 2 over 1. So when you multiply, you do top with top, bottom with bottom. So 2 times 2 over 3 is just 4 over 3. Okay? And 2 times 7 over 3 is 14 over 3. Everybody understand this? Remember, I told you, make your peace with fractions. Okay. At this point, what I would recommend is let's get rid of denominators. Okay? Just to make our life easier. So how our denominator here is 3. So what do we do to get rid of 3? We multiply the entire equation by 3, right? Every single term gets multiplied by 3. So I'm going to write this down. By this, I mean everybody's going to get multiplied by 3, Okay? All right. So let's see. Who can tell me what terms do I get? What happens in the first term?
15.
So 15x. Next. Let me put a parenthesis like this because of the plus and minus. Next. What happens when you do 4 over 3 times 3?
-4.
-4. So you get -4x. Next.
14.
Plus 14 equals 36. All right. Questions on this step? No? Okay. And now at this point, notice that fractions are gone. Just simplify and finish solving. So 50. So this is 11. So 11x equals, I'm going to move the 14 to the other side. So 13 minus 14. What is that? 22. And 36 minus 14 is 22. Yes. And now divide by 11. So we get that x is 22 divided by 11, which is
11.
2.
Oh, my bad.
Right? So we get x equal to 2. So once we find that x is equal to 2, first of all, this is telling us now that there will be a solution. So we are in the case in which the lines cross, okay? So we already know the x. Now what do we need to look for? The y, because we're looking for a point. We know the x, we need the y. How do we find the y? Well, you do what you want now. You can either put x equal 2 into any of the two equations and solve for y, or you can take advantage of this. Notice that right here, we already solved for y. All you have to do is put x equal 2 in here and find your y. Do you understand what I'm saying?
No.
No? Okay, so we know that x is equal to 2. Okay, and we have that y equals this. So if you put a 2 here for x, you get your y. Just combine. Right? Or if you don't want to use this one, but then you need to do this work twice. Then you get your x equal to, put it in top in any of the equations that you want, and then solve for y. For example, if you put 2 in here, that would be a 10. So you get 12 minus 10, that's 2, divided by 2, so y will be 1. Okay? Do it however you want. The thing about this one is that you have to add the fractions, which is not a big deal because the denominators are the same. But if you don't want to deal with this, then you may want to plug it into the origin if you don't want to deal with the fraction.
I had one more question. You had multiplied all those numbers by 3 because you did it by the denominator? It always has to be the denominator?
The LCD. In this case, because the only denominator is 3, then by multiplying by 3, then we're good. But imagine this would have been over 2. Imagine that this was 5x over 2, if we had something like this. What do I need to multiply by if we had a 2 here?
So it has to be against 2.
6. Because you need to find the LCD, the number that simplifies both 3 and 2 at the same time. So the minimum common multiple.
Okay.
So that can be divided by 3 and 2 at the same time. So remember, you want something that when you multiply, it will cancel all denominators at once. If you multiply by 2, it will cancel this one, but it's not going to cancel this guy. If you multiply by 3, it will cancel the 3, but not the 2. Now 6 does the job. It will cancel both.
Okay, I understand. Thank you.
All right. Okay. So again, if you are comfortable adding the fractions, plug in here. If you don't want the fractions, plug in the top. Okay? Up to you. So I'm just gonna plug in what we have. So now what I'm gonna do is I'm gonna plug x equals to 2 into y equals -2 over 3x plus 7 over 3. So we get that y is gonna be -2 over 3 times 2 plus 7 over 3, and then compute. So that's -4 over 3 plus 7 over 3. So denominators are the same, so we just combine the top. So we get 3 over 3, which is 1. Okay? So y is equal to 1. So the solution, remember, the solution is a point. So the solution is going to be the point. What's the point?
1.
2, 1. Remember, a point is something of the form x, y. So make sure that you write 2, 1, not 1, 2. Okay? The x comes first, the y comes second.
Oh, because the x is 2. Alright.
Okay, right here. All right, questions? Did you understand this? Okay, so again, this is nice, but if I were going to solve this problem using whatever method I want, unless you're being told use this method, if you're just being told solve the system, you do it however you want, however you think is easier for you. Okay, if I were going to solve this, I wouldn't use this. I would use the addition method. Okay, so let me explain to you how that works. Then we're gonna write it out in steps like we did in this one, and then we do more examples. Okay, so let's solve this one using the addition method. The idea is a little bit different. The good thing about this is that you really don't have to think. It's a procedure that you do over and over again. Okay, you solve for one variable and then plug into the other one, solve the equation, you get your value, plug it into whatever you solve for, and then you get the other value, you're done. The thing is that sometimes it will be painful because of fractions and so on. Now, if you want something nicer, there is one nicer, but you need to pay a price. You have to think a little bit more. Okay, so let me show you. Alternative. Okay, so let me rewrite the system. So that's 2x plus 3y equals 7. And then 5x plus 2y equals 12. Okay, so here is the idea. So first of all, you need to understand that equations, you can add equations. So how do you add two equations? Well, you add the left part with the left part and the right part with the right part. Okay? So for example, if x equals y and a equals b, those are two equations. If I add them, what do I get? That means if I do x plus a, that would be y plus b. And hopefully this makes sense to you, right? If x is the same as y and a is the same as b, if I do x plus a, it's the same thing as doing y plus b. Do you understand this? So you can add equations this way. Left part with left part and right part with right part, and you get a single equation. Okay, we're gonna take advantage of this idea. But before we do that, we need to prepare our equations. We want to add the two equations in such a way that one of the variables will disappear. When that variable disappears, then the equation that you have left over has only one variable and you solve. Okay? Now, for variables to disappear, what must happen? When you add two things, first of all, here when you add, of course, you will add x's with x's and y's with y's, right? Like terms. So what must happen for one of the variables to disappear? So when you add two numbers, when is it that you get 0? Disappearing here means getting 0. So they have to have the same absolute value, right? They have to be the same number, just that one is positive. I mean, not the same number, but the same symbol, but one positive, one negative. Like if you have a 2, then you need to have a negative 2. Do you understand this? And so on and so forth. So we need to make sure that at least one of the variables have the same number as a coefficient in front, but with opposite signs. So one positive and the other one negative. Here, unfortunately, all the numbers are different. Yes? So first, we're going to decide what variable we want to eliminate. So which one would you like to eliminate? Doesn't matter. Just tell me which one do you want to eliminate. X. Okay. So we have to make sure that in front of x, we have the same number, but with different sign. Okay? Now, we have a 2 and we have a 5. Now, remember, when you have an equation, you're allowed to multiply the equation by whatever you want. As long as you multiply everybody, it doesn't change the equation. So what do you think we can multiply? Both equations doesn't have to be the same. The first one by something, the second one by something else, so we get the same number in here. So this is like finding LCD. Think about common multiple. What's the common multiple between 2 and 5? The minimum common multiple. 10. So that means that we can make a 10 show up in here. Okay? How can we make a 10 show up in the first one? Multiply by 5. How can we make a 10 show up in the second one? Multiply by 2. Does everyone understand this? So that will be our first step. We're going to multiply the first equation by 5, the second equation by 2. Now, I'm going to fix that soon. So, let me name this R, because it's not exactly that, but that's a good starting point. So what I'm going to do is, I'm going to take the first equation, I'm gonna multiply by 5. I'm gonna take the second equation. I'm gonna multiply it by 2. We're gonna fix this pretty soon. It's not exactly this, but you will realize what's gonna happen. So if we multiply the first equation by 5, what new equation do we get? I say quotation mark because it's not really new. It's the same, but it looks different. So what equation do we get if we multiply by 5? 10x plus 15y. Everybody has to be multiplied. If you only multiply the x, you are changing the equation. Remember, everything has to be multiplied. So 10x plus 15y equals 35. Anybody understand this? Now let's do the same thing. What will be the new equation that I get in number 2? 10x plus 4y equals 24. Now, what's the problem here? If I add, the x's are not going to cancel. We're going to get 20. So I need one of these guys to be a negative 10, right? So how can we do that? Well, just make one of these numbers negative. So for example, if the first one was a 5, then let's multiply the second one by a negative 2. The negative is so I get the opposite sign. Do you understand this? If the original equation already had a negative here, a minus 5x, then I don't have to do that. I just multiply by 2 and I get my negative already for free. Does that make sense? But you want the opposite sign. But then if you want a negative here, you have to put a minus. If you want it on top, then you put it in the top. It's up to you. So let's fix it a little bit. When we multiply by negative 2, we get negative here. This would be a negative. And this would be a negative. Are we good now? So we changed the equation. We got something equivalent, but with the nice property that now the x's, they have the same number in front, one positive, one negative. What's the advantage of this? That if I now add the two equations, what's going to happen? Remember, you add left with left, right with right. What happens if I add the left part? So the x's are gone because 10 minus 10 is 0, right? Then we get 15 minus 4. That's 11y equals, what's 35 minus 24? 11. Do you understand this? So now we can easily figure out what y is. So what is y? Y is equal to 1. So we found y. And once you have y, what do we do? How do we find x? Well, go to the original problem, plug in your y, whichever your favorite equation is, and so forth. Okay? So now what I'm going to do is, I'm going to plug y equals 1. I'm going to plug it into the first equation. Into 1 to solve for x. So we get 2x plus 3 times 1 equals 7. And then finish solving. So we get that 2x is going to be equal to 4. Let's subtract 3. So x is 2. And then, of course, we get the same solution as before, right? The 0.2, 1. But hopefully you will agree that at least, this is shorter, quicker, and nice. I mean, we never saw a fraction. Did you see a fraction anywhere in here? No fraction. And the other one was a little bit longer, and we had to deal with the fraction, okay? Now, the price that you need to pay for this, I guess, nicer version is that you have to think a little bit. You need to come up with these two numbers, the 5 and the negative 2, okay? You have to think about, okay, what do I need to do to be able to get this nice cancellation? And I kind of already told you what's the recipe. Once you pick the variable that you want to eliminate, just find the minimum common multiple of the coefficient. It's like finding the LCD, okay? And that tells you what you need to multiply one and the other to get that minimum common multiple. And always remember that you want opposite signs. So if they are both the same sign, you have to make one positive and one negative. Like in this case, they both are positive. So one of my numbers that I multiply must be positive and the other one negative. If they already have different signs in here, then I just multiply by two positive guys. Okay? Because I already have the different signs. That's all. Any questions? This is called addition because we're adding the equation, but sometimes people call it elimination method. Like the book calls it the elimination method because we are eliminating one bit. Multiply to eliminate. Is that okay? All right, so let's see more examples of this. So again, what's written here is exactly what I just told you, okay, in words. You can read it later. I'm just gonna read it to you, but it's exactly the same thing, okay? So this is very important. You have to make sure for this to work, the equations have to be in standard form, meaning your x and your y, they have to be both on the same side, equal to a number, okay? So you have to rearrange the equation if it's not given to you in a nice way. Okay, so put the linear equations in standard form, the x's one below each other, the y's one below each other, okay? Then select the variable that you want to eliminate. That will be the one that's easier for you to find the minimum common multiple. In the previous problem, it didn't matter, but sometimes it matters, okay, as we see in the examples. Once you do that, then multiply each equation by a suitable number so that the coefficients of the selected variable in step 2 in each equation are opposite to each other. In other words, they are the same number, but one negative and the other positive. In other words, before we wanted to have a 10, right, in front of the x, but we needed a positive and a negative 10. Okay, that's what this sentence is telling you. And then I'm telling you this number can be the minimum common multiple of the original coefficients. We have 2 and 5. The minimum common multiple is 10. That's the number that you need. Okay. So just find what you're missing to multiply. Once you have done that, then add the two equations. When you add them, because we have the same numbers in front of that variable but with opposite sign, they will always cancel. So that variable is gone. Okay? So you will get a linear equation with only the other variable in there. Solve it. And once you have that solution, then go ahead and plug it into any of the two equations and finish solving to find the other variable. Okay? That's exactly what we did. So let's go ahead and let's do these problems. Okay? For example, I'm going to use this method just to show you the idea. But you have to learn how to identify which is the right method to use. Okay? Let me tell you, here we're going to use this method because we are practicing this technique. But for example, for number 1, I will definitely use this new idea, the addition method. Okay? Because if you try to use substitution, it's going to be a pain, just like what we did in the previous example. A bunch of practice. Now, number 2, we're going to do it this method, but number 2 is very easy if you use substitution. For example, here it's very easy to solve for y. You put it here, and you're basically done. Or here you can solve for x, plugging in the top, and then you are easily done as well. So here substitution will be also equally easy. Okay? And here, again, this is the one that we were doing before. Here I will use substitution also solving for x. Okay? So, but anyways, we're going to use this method to practice it. But at the end of the day, when I give you a problem, it's up to you which one you want to choose. Unless I tell you use this particular method. If I just say solve, you need to pick whatever you want. Okay? All right. So let's go ahead and let's do this. Solution. So for the first one, we have 6x minus 9y equals negative 15. And then 5x minus 2y equals negative 40. Okay, so we have to look at this and we need to decide what variable we want to eliminate. And remember, think about what's the easier one that we can find the minimum common multiple among the coefficients. So let's see, x here is 6 and 5, and y here is 9 and 2. Let's forget about the minuses and plus for now, okay? 6 and 5, 9 and 2. Which one is easier for you to find the minimum common multiple? Let's see, pick a variable.
6 and 5.
Okay, so what's the minimum common multiple?
6 and 5.
What is the minimum common multiple?
He said 30.
What do you think?
I'm gonna go with 30.
But do you understand why it's 30?
Because it goes within both.
Exactly, and it's the first one that goes within both, right? Because 5 is 5, 10, not good for 6, 15, not good, 20, not good, 25, not good. 30 is the first one that works for both. Okay? If you were to go with 9 and 2, then it's 18, right? But anyways, whichever. Okay, so let's go with 30. So that means I want to have a 30 in front of the x. Now remember, one of them must be positive, the other one has to be negative. Okay? So let's decide which one is it now. Let's see, for the first one, which one do you want positive and negative? Which one do you want positive? The first or the second? The first. So we're going to multiply the top by something positive, and then the bottom we need to multiply by something negative. Yes? So we have a negative in the bottom. Remember, we want a 30 in here. So what do I need to multiply the first equation by? By 5. And what do I need to multiply the second equation by? Negative 6. We want a negative, remember. It's important. You have to have the different sign. Multiply by negative 6. Okay, so let's do it. So what's the first equation? What do I get? What's my new first equation?
30x.
30x
minus 45y
minus 45y.
equals negative 45.
So it will be 25, so negative 75, right? 15 times 5 is 75. 25 carry 2, 5. So, okay, so that's my new first equation. Now, what's my new second equation? What's my new second equation? Just multiply every single term by negative 6. That's all you have to do.
Negative 30x
Negative 30x
plus 12y
plus 12y
equals 160.
and no, 240.
240.
To be careful. Positive 240. Okay, any questions on this? All I did was I multiplied every single term by negative 6. Okay? Now what do we do? Notice that now we have what we wanted. We have the same number in front of x but with different sign. Why do we want to make this 4? Why do we want to make this happen? I've been talking here.
You want to find y, simplify for y.
So what are we supposed to do?
It's going to be 33y.
So we add the equations, right? You add them. So we add. I mean, it's interesting because I always think that you guys understand, but then in the exam, I only saw that 5 or 6 passed the exam, the rest failed. So, you know, if you don't understand, you need to ask and you need to pay attention. Otherwise, it's not going to be good. Okay? And remember, this is not high school. If you fail, you fail. Okay? And so, I'm trying my best to make it as simple as I can, but if you don't cooperate, there is nothing I can do. And we just get more intense as we move forward. So, make sure that you understand what we're doing. Okay? All right. Anyways, in here, what we do is we add. Why? Because that's why we wanted the same number with opposite signs. So when you combine, they cancel. So the things cancel. So we get negative 45 plus 12, which is negative 33. So we get negative 33y equals, so what's 240 minus 75? So that's 5, then 8, that's 6, so 165. And we get positive 165. Yes. And now we divide. So y equals 165 divided by negative 33. Okay, can we simplify this more? Let's see, that's 11, 12. Okay, this is divisible by 3. What is it? So, oh, it becomes negative 5 entirely. Okay, good. By the way, notice that if this would have been a fraction, you will have to plug that fraction in and then solve, okay? So that means, anyways, so we get here y to negative 5. 5 is 15, good. So now we have y. What's the next step? Where?
Whichever equation you pick.
Whichever equation. So which one do you wanna pick? Exactly. So let's see. Why the bottom?
Smaller number.
Because smaller number, right? I mean, it doesn't matter. But you put in the top, you have to do the 9 times the 5. Okay? I would rather do 2 times 5 than 9 times 5. It's just a matter of taste. But... Okay. So I'm gonna plug y equals negative 5 into equation number 2. So we get 5x minus 2 times negative 5 equals negative 40. And now solve. So 5x plus 10 equals negative 40. So 5x is negative 50. You subtract 10. So x is negative 10. Dividing by 5. So what's the solution? The solution is the point. Okay. All right. Questions? Any questions?
Man, I have too many questions.
That's fine. I mean, most likely half of the class have the same question, just that they're not brave enough to speak out. So just do it.
We're gonna have to do the whole equation again, so
I mean, there are 2 more examples.
okay, all right.
But is there anything in particular that's bothering you? Everything is bothering you?
Not that, I mean, I don't know, like the whole, let's just go to number 2 and I'll see if I can have something.
All right, so let's do number 2. Okay, so what was number 2? That's 3x plus y equals -5. Now, this one will be easy. It will be easier. 3x plus y equals -5, and then x minus 2y equals -4. Okay, so here is my advice. If you're solving a system and you see one equation that has a 1 in front in the variable, in other words, if it has no number, the variable in front, just eliminate that variable, because it's very easy to eliminate that variable. For example, I see this equation and I want to eliminate the x because it has a 1. All I have to do is match this with this one. So I multiply this equation by what? By 3, but it should be -3, so that they have opposite side, right? And you don't have to touch the first one, okay? Or you could eliminate the y over here. How can we eliminate the y? What do I need to multiply this by to match this? By 2. Not -2, 2, because this is already plus or minus. That's all I need. Do you understand this? So for example, just to change, because we have been eliminating x all the time, let's eliminate the y now. So I'm just going to multiply the top by 2. So I have a 2 here, and then they will cancel. Okay? But you can easily also multiply the bottom by 3, and the x will cancel. Does that make sense? All right. So and I'm going to go ahead and I'm going to multiply equation number 1 times 2. So that becomes 6x. By the way, a common mistake that students make is that, you will multiply this one by 2 like you were doing in the beginning and then not touch the others. Be careful. Everything has to be multiplied. Okay? And then the second one, I'm just going to rewrite. No need to touch it. Why? Because now I have everything I need. When you add the 2 equations, this cancels, so we get 7x equals -14. Yes? Let's combining. And then what is x? -2. I have to divide by 7. 14 divided by 7 is 2, right? So we get -2. So we have our x. Once you have your x, we need to figure out y. Now here there is an equation that's very easy to find y. Which one should you use to find y? The top one, right? Because y is already by itself. You just move this to the other side, right? So you put the -2 here. That's -6. Move it to the other side, and you're done. So I'm gonna use number 1. So we get 3 times -2 plus y. Let me say using 1 equals -5. So what is y? What is y? 1. So what's the solution? -2 common. Questions? Did you understand this? Right, so why don't you try, let's say, try number 3 on your own. So number 3, the first thing that you need to do is put it in standard form, okay? So in other words, you have to bring this x to the other side before you activate this process. The x and y have to be on the same side. So that's 3x minus 6y equals 12. I feel like we already did that one, so let's do something else. I'm gonna put x. Let's put 9x minus 18y equals 36. Just so that the numbers look different. That's all. And then negative 2y equals negative x plus 1.
Start 18 or
18. Okay, so do this one. I mean, this is the same thing. Okay, let me just write here 9, negative 18, 36. It's just that problem we had done it already before, so I just want to change it. But it's essentially the same problem. All I did was multiply the first equation by 3. Okay. So give me 2 minutes, 3 minutes. Well, I'll take a 10 minutes. Okay, the first step would be to put this, in standard form. So let's do it. So that's 9x. The first one is fine. I'm just gonna modify the second one. I'm gonna bring the negative x over. So that will be positive x minus 2y equals 4. Okay. So at this point, what should we do? What equation do we need to modify? What's the easier one to modify? The first or the second? Tell me what equation is the easier to modify and what's the easier variable to get rid of?
X is the easier one to get rid of.
And how do we do that?
By multiplying by 9.
Which one?
9x.
The second equation. By multiplying. Notice that there's a 1 here.
By 1.
Right? There's a 1 here. So I multiply this one by negative 9.
Yeah.
Right? Also, in this case, notice that everything, but I wouldn't recommend this. But everything is a multiple of 9, so you could also divide by 9 the first equation. Okay? Or divide by negative 9. Better. But let's stick to multiply. So I'm going to go ahead. I'm going to multiply equation number 2 times a negative 9. You could also, okay. But again, I'm doing that inspired by the fact that there is an x here with a 1 in front, so it's very easy to put the number that I need. It's just whatever I see in the top equation. Just multiply by that. Okay, you don't have to think much, but change the sign to make sure that they, that they have opposite sign. Anyway, so 9x minus 18y equals 36. I don't touch that one. Now my second equation becomes multiplying by negative 9, negative 9x plus 18y, okay, equals negative 36. And then you already realize that actually when you add, actually everything simplifies, right? Let's see, if you got 36 equal 36, it's because you did the other method. You didn't use this method. Remember, here we're practicing this technique, okay? So in this case, what happens? This cancels, but this also cancels, this also cancels. So you end up with 0 equals 0. Again, it's the same thing as 36 equals 36 or 20 equals 20. It's exactly the same situation, okay? So we get something that's always true. So this is always true. So that's what tells you that then there are infinitely many solutions. So we are in the case of the same line. So how do we write it? So how do we write this? So the solution is going to be points of the form x comma y such that, and now here just put whichever equation you want. I'm going to put the first one. So that 9x minus 18y equals 36. Okay? Or you could just write the second equation, x minus 2y equals 4. That one is more pretty. Maybe you may want to write that one. It doesn't matter, whichever you want. Okay? So, for example, I guess I prefer that. So, I prefer that. Which you can obtain, just take the first one, divide by 9, you get this one. Okay? So, it's the same equation. So, that's how you write it in the case of infinitely many solution. You write this form, and this means all points x comma y such that the entries is not whatever you want. They have to lie on this line because this is the line that we're talking about. Okay. All right. Questions? Did you understand this? So let's practice the following. I'm going to show you some problems. I want you to tell me what's the method that you will use to solve it. Not that you will use. Which one is the easiest one to use to solve? Okay. So let's not worry about solving now. I got this from the book. Let's just, if we have time, we solve something, but then at least the purpose of this is to be able to look at it and decide what would you use. Would you use substitution or would you use elimination? Okay? So let's see. Let's look at number 64. There are two problems here, part A, part B. Okay. So part A. What do you think would be the better method to use?
Elimination.
Elimination method, which is elimination slash addition, is what we just discussed. Okay. Very good. So this one. So for A, we will use elimination. Okay. If you try to solve for a variable, you're gonna get fractions, and it's gonna be the painful way. How about the second one?
Elimination. Addition.
So you could do elimination. Elimination addition is the same. The other one is called substitution. So, okay, so if you say elimination, thinking about substitution for the first one, no. Okay, elimination addition is the same. Okay. Now for the second one is screaming at you to use substitution because you already have one of the variables solved for. You already have x equals something. What you have to do is put that in here, and you get your y. Do you understand this? Otherwise, the other method, you have to bring the y over, then multiply by something. You have to do more work. Here, you just plug in and done. So this one will be just substitution right away. Okay? Here is a key. This is telling you to just substitute. Does that make sense? And how about the next one? What would you use for part A? Substitution, right? Once again, this equation here is telling you, hey, plug me in into the second one. Okay, it's already y equal to something. So substitution. And how about B? What would you use here?
Elimination and addition.
So elimination, right? Elimination, addition, same. Elimination, addition. So again, you need to do problems to get a feeling of which one is the best one to use, okay? And just trying to give you some hints. And if I look at a problem and I see, even if it's not like this, but if I see just a y or an x, I'll probably just use substitution because it's very easy to solve for that variable and plug in and done, okay? But now if I see something like this, that the x's and the y's, they have numbers in front, all of them and so on, I'll probably go with addition slash elimination method, okay? Unless I see that everything is a multiple and that I can nicely divide and so forth the variable. But here, 3 and 15, they cancel, but the 7, they don't. That's so fractions. If you solve for a variable, you get a fraction. Same thing here, okay? Here, these guys are not going to cancel. So, you will get a fraction. So, that's what I thought which one to use. Okay, so let's see. We have like 4 minutes left. Go ahead and do 64. Now you know what method to use. For example, do B. That's faster. See if you remember how to do it. Do B. Let's just do one problem. We have 3 minutes. So do B. I'll give you 2 minutes and then do it together. So let's do this. And on Thursday, to remind the other class of what we just discussed today, I'm going to do the 2 A's and the other B. And that way, when you watch the video, you will get all the solutions. Remember, just plug in into the second equation and solve for y. That's all you have to do. And once you know y, return to the first one, put it to get your x. Okay, anybody has a solution? Anybody? It shouldn't take long. All right, so let's do it. Okay, again, does everybody understand that here we just plug in? Yes? Okay, so then equation number 2 will look like 4 times 4y minus 3 minus 2y equals -6. So this was x, okay? I just replace it by 4y minus 3, which is coming from equation number 1. And now we solve. So that's 16y minus 12 minus 2y equals -6. So that's going to be 14y equals, I'm going to add 12, so that's 6. And then y is going to be 6 over 14, which simplifies as 3 over 7. So y equals 3 over 7. Okay? So now that we know y, then let's go to the first one and figure out x. So x is going to be 4 times 3 over 7 minus 3. So what is this? That's 12 over 7 minus 3. Remember, this is over 1. I'm going to multiply by 7 top and bottom to make the denominators the same. So we get 12 minus 21. What is that? It's -9. Oh, -9 over 7. So what's the solution? -9 over 7, comma 3 over 7. All right. Questions? Any questions? No? Okay, good. All right, so let me give you a summary. Remember, we're talking about systems of linear equations. Remember the idea? These are 2 lines, and what we are really trying to figure out, let me go back to our original discussion last week. You know, we want to see if we can solve the system of equations or not. So because these are 2 lines, the question is, will they cross or not? If they cross, that means there's one solution, and it's the point of intersection. If they don't cross, then there is no solution, meaning the lines are parallel. Okay? There is also this case in which there could be infinitely many solutions, and this is the case when the 2 lines are the same. Okay? So they are on top of each other. And we discussed the graphical approach, but that's not good at all to find solutions. So to find solutions, what we do is the substitution or addition / elimination method. So in here, we're going to see examples now that for your reference, and when you watch the video, if you haven't done that, you will see it. But basically, you know, here I wrote down for you the steps for the substitution method, okay? So basically what you do is, you look at the 2 equations, you have to pick a variable that is easy to solve for. So pick an equation, pick a variable, solve for that variable using the selected equation, and then plug in the result into the other equation. You're going to have a linear equation in one variable, solve it, and once you know the value for that variable, plug it in into any of the equations to find the second variable. That's the substitution method. That's what we're going to do now in the examples. And then here you can also read the steps for the addition method. This one is a little bit more, I would say, more sophisticated, because it's not just moving around, solving and plugging in. Here you have to think a little bit, which is the idea is that you want to change the 2 equations in such a way that one of the variables is going to have the same coefficient in front, but one positive, one negative. So when you add the equations, that variable cancels. That's why we call it elimination also. Okay? Then you solve for the remaining variable, and then once you know one variable, you plug in to get the other. Okay? Again, you can read this later, but you're going to see it in action right now in the examples. Okay? All of this was explained and done on the Tuesday video. Okay? So I strongly encourage you to watch it if you haven't done so. Anyways, let's now put it in action. So the first thing that you need to be able to do is, because typically this is what's going to happen. You're going to be given a system, and then it's your job to decide, unless the question tells you specifically how to solve it, like one method to use, you need to decide what method you're going to use, which one is the best one to use. Okay? So let's do that. For example, this one was done last time using the substitution method. So here we use substitution. And the reason why substitution is a good method to use is because of this. You see, one of the equations already has x equals to something. So here, one of the variables is already solved for. Okay? So it's pretty easy. All you have to do is plug this into the other equation and finish. you can figure out the y, and once you have your y, you put it here to get your x. Okay? So if you see something like this, you should probably go with the substitution approach. Okay? Now, if you look at part A right here, if you try to use substitution, that's fine, you can do it, but what's going to happen is that when you solve for one of the variables, notice that the numbers are not going to cancel, so you're going to end up with fractions. Okay? And then when you plug into the other one, you will have to deal with fractions. So if you see something like part A, this is definitely an elimination / addition method. I typically call it the addition method, but in the book, if you read it, it says elimination method. So, it's the same. So when it looks like this, that none of the variables seem to be easy to solve for, like you're going to end up with fractions, you should probably go with the elimination method instead. Okay? And again, we're going to practice these ideas now. For example, 65. Can you tell me, part A, what method would you use to solve this?
Substitution.
Substitution. Why? What equation is? So we have equation 1, equation 2. Which one tells you that you should probably use substitution? Equation 1, right? So if you look at equation 1 right here, you already have y equals to something. So all you have to do is grab that and plug into the other equation, okay? And then that will allow you to find x pretty easy. And how about part B?
Elimination.
So here we should probably use elimination. Again, you can use substitution, it's just that it may be a little bit more complicated because you will have to deal with fractions and all of that business, okay? So elimination or addition. Do you understand this? At least just by looking at it, more or less what should be the more suitable method to use. Remember, graphical approach, is get away from that one, okay? That one is not nice. It's either substitution or elimination to actually find a solution. Okay, for 64B, we did it last time. Let's do the other three. Okay, so I'm gonna do 64A to explain elimination, then I'm gonna give you some time, and you try 65B, so you practice the elimination that we will explain, and then I explain the substitution by doing 65A. All right, so solutions. B is already done, so let's do 64A. So we have, the other way around. Elimination, then you're gonna do B, elimination, and then explain substitution. But I guess substitution doesn't require too much explanation. But just in case. Okay. So 6x plus 3y equals -5. All right, so we want to solve this system. Remember, the idea here is we're looking for an x and a y that works for both equations, okay? That's what we're trying to do. So we want to do this by using the elimination method. The idea of elimination is that first we need to pick a variable. What variable we want to get rid of, okay? And second, then we need to multiply each equation, either one equation or maybe both, by a suitable number so that we get the equations in the form that we want. What do I mean by that? For example, let's say that we want to eliminate the x, okay? These numbers are not good for me because if I add this equation, I'm going to get 14x. This thing's not going to cancel, okay? So I want to have the same number in front of the x's, only that one needs to be positive, the other one needs to be negative. So that when you add, they are gone, okay? They cancel, they get 0. So first you need to decide what you want to eliminate, x or y. In a case like this, for example, it's really easy to eliminate the y. Why? Because notice that 15, you have here a -15 and here you have a 3. Yeah. And it turns out that 15 is a multiple of 3. So it's really easy to put a 15 in here. What do I need to do to the second equation to have a 15 here? Multiply everything by 5. You're done. Okay? Now, if you wanted to eliminate the x, for example, the thing is that these two guys are not multiples. And sometimes, usually this is what happens. Then what do? Well, you want to have here the minimum common multiple. So what's the common multiple? The smallest common multiple is like LCD when you're adding fractions between these two guys. 24. So what do we need? So you want a 24 here. So what do you need to multiply the first equation by? -3. Okay, let's talk about the negative now. Right. So let's say by 3, that will give you a 24 here. Yes? Yeah. And this one? -4. By 4, that will give you a 24 here. Now, one of them has to be negative. You pick whichever you want, either -3 on top or the -4 in the bottom. It's whatever you want, okay? Now, that seems like a little bit more work because I have to modify both equations. I would rather modify one. So I'm gonna go with the y. I will eliminate one, okay? So this is the thought process that you should have. All right, anyways, I'm gonna rewrite the system. The first equation, I'm not gonna touch it because I'm going to eliminate y. Now, the second equation, it's always good to write down what you're doing. The second equation, what do we multiply by? By 5. So I'm going to do 5 times equation number 2. Remember, this is equation 1, and this is equation 2. Okay? So who can tell me what equation do I obtain if I multiply equation number 2 by 5? What do we get?
30x.
30x
Plus 15y.
plus 15y.
Oh, it's just me.
Well, you are the one answering, so
-30.
equals what?
-30.
What's 5 times 5?
Sorry. I'll leave the 6 next to the thing.
Negative 25, right? All right, so again, this is the same system as before in the sense that it has the same solution. The two equations are equivalent. It's just that now this one looks better than this. Why? Because now if you look at the variable y right here, okay, the number in front is the same. It's just that one is positive, the other one is negative. Okay, the same in absolute value. Why is this benefit? Why is this beneficial for us? Because now we add the two equations. When you add equations, you do left with left and right with right. Okay? When you add them, what's going to happen with the terms that have the y? They're gone because they are opposite, right? That's why we did this. That's why we wanted 15 here. And that's the idea of this method. That's why it's called elimination. And then also addition because you're doing this so you add the equations now. All right, so let's add them. So the y's are gone. Everybody understand this?
Yeah.
So what do we get on the left?
38x.
38x equals, what do we have on the right?
57, -57.
Negative 57. And now we can solve for x. So x is negative 57 over 38. Questions? And let's see, can we simplify this? So 38, this is 19 times 2. So this is only a 19 and a 2. And 57, 19 times 3. Right? 19 times 3. Yeah, 19 times 3 is 27, carry 2. 3 plus 2 is 5. So that's 19 times 3. So we can simplify this. Take out 19, you get a 3. Take out 19, you get a 2. So that's negative 3 half. Okay? So x equals negative 3 half. Okay, questions up to here? Do you understand this? All right, so now that we have x, what do we need to do? Remember, we need to find y. Okay, we only know x, we need to know y. Now, what you do is, well, go to your favorite equation, any of these two, plug in your x, and then you figure out the y. Okay. Now, my advice to you is, in this case, it doesn't really matter. Just because notice that the coefficients of x in both equations, I'll plug in here because this one is just smaller, but the coefficients are even, so that's nice because then this fraction will cancel nicely, okay, with the 2, because that's division by 2, so you can divide by 2, okay. Now, if this would have been a 7, for example, if this was a 7, then I'll probably plug in here because it would be easier. If you plug in here, the 7 is not going to cancel with the 2, and then you need to keep dealing with the fraction, okay. So, just choose the equation that will make your job easier. Anyways, I'm going to plug in equation number 2. First, because it has a 6, but that's not really a reason because there's an a on top, but it's because 6 is smaller, so I'm going to work with smaller numbers, okay? That's the reason. Okay, so now what I do is we're going to plug x equals negative 3 half into equation number 2, okay? All right, so we get 6 times negative 3 half plus 3y equals negative 5. And now, as you can see, this is an equation with one variable. We can solve it. But let's see. How do we carry out this product? What is that equal to? What's 6 times negative 3 half? Do it. Tell me, what is it? I mean, you need to know this at this point. If you don't know this, you'll be in trouble. So, what is it? What is this equal to? What do we get? Remember, when you multiply fractions, you do top with top and bottom with bottom. A over B times C over D. What is this? That's A times C over B times D. And then you simplify. You can do it this way. Remember, you can think of this 6 as being over 1.
So it would be negative 9.
So it will be negative 9. Nice. I mean, this is not supposed to be hard. You do 6 times negative 3, that's a negative 18. 1 times 2, that's a 2. So that's negative 18 divided by 2. That's negative 9. Typically what we do is, instead of multiplying and then simplifying, we simplify before we actually multiply. How do you simplify? Stuff in the top gets cancelled with stuff in the bottom. So this 2 in the bottom, I can cancel it with this 6, giving me a 3. And then you do 3 times 3, which is the 9. But then it's negative because of the negative. Do you understand this?
Yeah.
All right. The point is that this is negative 9. Okay? For example, I'm going to do it this way. The 2 cancel with the 6, giving me a 3, and then you do 3 times negative 3. Okay? Plus 3y equals negative 5. So now just solve for y. So we add 9 to the other side, giving me 4. So y is 4 over 3. So we have our solution. So the solution is the point. Remember, the solution is a point, x comma y. So negative 3 over 2 comma 4 over 3. All right. Questions?
When we solve it, we put it in.
When the solution of the system is a point, so you need to give me a point.
And you put curly brackets around the parentheses as well.
Because this is called the solution set. So a set, this symbol here, these curly braces, and what they're telling you is that you're writing a set. And then inside, what you do is you list elements. There's one element in this set. What is it? This point. Okay? But when you're doing the homework, you have to see. Sometimes they just want you to write x equals something, y equals something. So you have to see how they want you to answer the question. But typically, we just give the solution set. All right. Questions? Did you understand the idea?
Yeah.
Remember, the whole point is to have one variable with the same number in front, one positive, one negative. So you can add and cancel. So let's see. Try it. Do 65b. Copy it down here. That's 12x minus 5y equals negative 42. 12x minus 5y equals negative 42. And then 3x plus 7y equals negative 15. Okay, so try this one. Jasmine Buckner.
Here.
Giovanni Cage.
Here, you got it.
Oh my god, you got it.
You probably, you want me to tell you the secret why I remember? Okay, so first, when I look at your day the first time, for some reason I thought about kanji because of the, the thing. And then it's wrong, so I look at it, kanji comes to my mind, but then I say it's the other one.
He just does the opposite of what he wants to do.
It's always the opposite of what I want.
You should put a little post-it by your computer and like put the spelling out so you
Yeah.
can remember.
No, I have it here now.
You got it, you got it.
Jorge Carmelino. Michael John Chavez.
Here.
And then question, so that singer or artist or, okay, the name of that person, how is it spelled? Is it with a C? I didn't look
It's
it up.
with a K.
I was gonna look it up. It's with a K.
It's with a K.
And that makes the whole difference?
Kanye West?
You're talking about Kanye, right?
Yeah,
Yeah, it's with a K.
it's with a K.
What
And
is
that's
his
why
last
it's-
name?
No, because he's talking.
I'm talking about his last name.
Oh, you said.
But his last name is with a C.
Mine?
Yeah.
Oh, bro, that's
Oh,
nice.
But you're not-
Okay.
Yeah.
That has nothing to do with what.
No, he's thinking about Kanye. He's like, he thought about the pronunciation of the word Kanye, and he was like,
The
it's the opposite of
pronunciation,
that.
yeah.
It's Kane.
But listen, Kanye is with a Y.
Yes.
Ah, I see. So the Y is the one that makes the whole difference.
Yes.
Joseph with a G.
Yes.
I see.
Because your last name is with a K.
See.
Oh.
With a C.
Oh, see, I see the predicament now.
I see what you
understand
meant.
why you're.
Yeah, I got
Exactly.
it.
I was like, what?
You're like Kanye.
Singer.
I get it, yeah, I understand.
Yeah, I don't know. For some reason, I find it. You know, I'm learning.
Kanye.
Okay, Carsley Gallo,
Weird.
Shelly Gonzalez,
Here.
Jalen Jackson,
I don't know what it is. It's just nice.
Caitlin Kelly, Christian Lopez, Irene Martinez, Guadalupe Morales, Jasmine Palomino, Omar Peláez, Yaismel Reyes, Emily Rodríguez, Adrián Sarmiento, Sofía Sor,
Here.
Johnny Sosa, Yamir Valderas, Valderas.
So
Alright.
how do you pronounce your last name?
Saumel.
Salman.
Yeah, because it's S-A-U.
Yeah.
Usually people say Samuel. And,
Yeah,
then, and then when you write my email, they write Samuel and they never get it.
I read somewhere, but I was like, yeah, no, that's all right.
They say, I sent you 10 emails and you didn't reply. Well, I didn't get it.
Well, you were talking to the wrong person.
After we find one variable,
Uh-huh.
can we use the same equation that we used to find that one?
Remember, you're using if you use substitution, no. But the idea here is let's do it by elimination, right? So if you do elimination, just pick your favorite equation. Doesn't matter. Because remember, you're modifying technically both, right? Let's see, there's one variable here that's very easy to eliminate. Which one is it?
The 3x.
Yeah, the x.
The x, right? Does everybody understand why?
Yeah.
Okay. What equation needs to be modified to eliminate it?
The
The
model.
bottom by -4.
Very good. So you got a solution already?
Of course you do.
Yes. For one variable, right?
Finish it. Do the whole problem. Do the whole problem.
The day that there's a lesson about fractions, I will be the happiest person. It's weird.
I remember you have a review of fractions at the very beginning. Did
I
you?
know, but I hate fractions.
But you need to do it. Or
No.
they are not gonna go away. No, that's the problem. They are not gonna go away.
No, they will. They promise you they will.
Or get a calculator. There are calculators that you can put the fraction. We simplify. We add it. We do everything with the fraction. So get that type of calculator, and they're cheap.
Honestly,
very
yeah.
cheap.
I think I have the calculator.
I have one at home, so I will see the name and then I'll send you guys an email.
Yeah, because you
Yeah.
Put it on
And
blackboard.
then, you know.
I just step it up.
I think I multiplied the fraction wrong. I multiplied my fraction, I got another fraction.
You see,
That's
fractions are always
fine.
the
That's
problem.
fine.
I mean, what's 1/2 times 2/3?
Oh, don't ask me that.
I don't know.
Give me a second, I'm being serious. Fractions are not my strong suit.
Is that we've always been taught like the bigger picture rather than being taught like individual things, like fractions, like how do you solve a fraction? We don't know how to do that. We were never taught that.
It's one third, by the
Multiplication.
way.
They just assume for us to know.
Yeah, at school, like, we did
Yeah.
normal job with fractions.
That's why I'm so scared of fractions. I don't even want to see them. Don't.
Well,
We're just-
this is maybe a good news or bad news. At the end of this semester, there is a section that we have which is rational equations. And rational equation, this is a generalization of fractions. So we're gonna deal with fractions, but with variables
The whole
involved.
module
I
of just
really
fractions.
don't to
So
because I can't do it.
hopefully by the end of this course, you will know fractions, so then you don't have to worry about it.
Either I know it or.
You learned the basics, you did a good job.
All right, let's see. Do we have a solution?
I got stuck somewhere soon.
You guys talk. Anybody else has a solution? Let's try. It's okay to get it wrong here. It's not okay to do it wrong in the exam. But it's okay to say it wrong here. Okay.
That was good.
So what do you have?
Well, for y, I got negative 15 over 7.
Negative. So what's your solution? Give me a point.
No,
X,
I didn't
comma,
get-
Y.
I didn't
We
get
didn't
the
get that far.
I didn't get the x, is what I'm saying.
Okay. Who has an answer?
Never the end.
Anybody has an answer?
I know why I messed up. I want to get you an answer right now.
I'm using the calculator,
For
but
y, I
I'm
got
not.
negative 18 over 35.
Negative 18 over 35. And for X?
Still getting.
Still finding it. Okay, let's see.
No, I don't know.
Let's do it. Again, does everybody understand that we should eliminate, that it's easy to eliminate X, and therefore we just need to multiply the bottom equation by -4? Yes? All right, so let's do that. So the first one, we're gonna keep it the way it is. And then the second one, I'm gonna multiply by -4. Okay, so what do we get? We get negative 12x minus 28y equals positive 60. Okay. All right. So notice that now we have what we wanted. We have the number in front of the x. They are opposite of each other. So that means when we add, now we add the two equations. These guys are gone. So what do we get?
Negative 33.
So negative 33y, right? 5 plus 28 is 33.
Yeah.
Equals, and then what is this?
Negative 18.
A positive.
Oh, sorry,
8.
positive.
I forgot to
I knew
add
you
them
wrote
too.
it on my favorite positive, but I said a negative.
Okay, that's positive 18. So that means that y is going to be negative 18 over 33. So you made a
Yeah,
little,
I want to.
little issue there. Okay, now remember, if you see this, see if you can simplify, because you know, it's two big numbers. I mean, if these are the numbers, then that's fine. Then we need to deal with them. But sometimes you can simplify. Like for example, here we can. At least I know I can divide by 3. This is a multiple of 3, and this is also a multiple of 3. Okay, so simplify.
6 over 11.
So divide this by 3, you get a 6. Divide this by 3, you get 11. So y is negative 6 over 11. Don't forget the negative. Yes?
I see exactly where I messed up.
So we have our y. Now that we have y, what do we do?
Plug it into this.
We plug it into one of the equations to solve for x. Now notice that here none of the coefficients of y are multiples of 11. So that means we're not going to be able to get away from the fraction. Okay? So you plug in, it's not going to cancel nicely as before. That's fine. So then which one should you plug in? I would recommend the one that has smaller numbers. Okay? Even though you see a 7 here instead of a 5, these coefficients are nicer to deal with. Okay? It's a 3 and 15. Here you have a 42 and 12. Okay? So I would recommend to use the one with smaller numbers. I'm going to plug, but it doesn't matter. Okay? You plug in whatever you want. Plug negative 6 over 11 into equation number 2. So as 3x plus 7 times negative 6 over 11 equals negative 15. Now remember, if you don't like fractions, okay, that's fine. Get rid of them. How do you get rid of fractions? When you have an equation and fractions show up, how do you get rid of them? Find the LCD and multiply the equation by the LCD. In this case, there is only one denominator, which is 11. So what's the LCD? 11. So just multiply everything by 11 and get rid of it. So I'm going to multiply the entire equation by 11.
You wouldn't just put 7 over 1 like you did the other equation?
I mean, you can multiply these two, but that would be negative 42 over 11. That's not going to do anything. I'm just going to get rid of the 11 right away. So multiply everything by 11. So we're going to get 33x. Now in the next term, the 11's cancel, so we get negative 42. That's 7 times negative 6 equals. And now we need to do negative 15 times 11. So that will be negative, and then that's 165. There's a nice little trick when you multiply by 11. If the number has 2 digits, all you have to do is open the digits and then add them and put the result in the middle. Because that's really what you do when you multiply by 11.
Wait, can you repeat that?
Just open them and put the sum in the middle.
Oh.
So 1, 5, and then 1 plus 5 is 6.
Wow, I would never thought of
I literally did that yesterday for picture.
And there is a little catch. If the sum is more than 9, you need to carry it to the next one. So if it's 83 times 11, you do 83, but the sum is 11, so you put 1, and then the 8 becomes a 9. So it will be 913.
Quick math.
Okay. Because if you think about it, that's what you do when you multiply by 11. Okay. Anyways, or use your calculator. Remember, you have a calculator, so then use it if you have. All right, so at this point, notice that after we multiply by 11, we have no longer the denominator, so now it's pretty easy to solve, right? So what should we do?
Add 42.
So we add 42, so we get 33x equals, so we need to do 165 minus 42, so that's 3. We subtract because they have opposite sign, okay? So that's 3, that's 2, so negative 123. So negative 165 plus 42 is negative 123, and then divide.
We can do 11 again.
And can we do 11?
Oh, no, wait, no, it's 123.
No. If it was 132, then yes.
Or 121.
But it's 123. 123. We cannot do 11. Can we do 3? Yes, we can do 3. Remember, the divisibility rule by 3 is if you add the digits and you get a multiple of 3, then the number is divisible by 3. So 1 plus 2 plus 3, that's 6. That's a multiple of 3, so we can divide. So divided by 3, you get 41, right? And here you get 11.
But negative.
So we get negative 41 over 11. So what's solution?
Negative 41 over 11.
Negative 41 over 11, comma,
Negative.
negative 6 over 11. Always remember to put x comma y. So sometimes students do this correctly, but then you write y comma x. So you write this number first and that one second, and then it's wrong. Okay? So make sure that you put x comma y, remember. Okay. So this is the x, this is the y. Questions about elimination / addition method. Do you understand it?
Can you do one for substitution?
Yeah, we do one with substitution now. You okay with this? All right. So now let's go ahead and let's do 65A that we claimed that it was, it was more suitable to use substitution for that one. Okay, so yes, but let me just tell you something. If this 7x was on the other side, let's put, which is not hard, and you can just move it, right? Then when you have a variable by itself, also addition is pretty easy because when you have a 1 in here, then you need to multiply that equation by the coefficient of the other variable to make it appear, okay? That's pretty easy to use addition. But anyways, let's practice substitution. So that was y equals 7x minus 5. And the other one is 3x minus 2y equals 16. Okay, so remember, what's the idea when you use substitution? You take one equation, solve for one of the variables, plug it into the other equation, and then solve. Okay? So in this case, we already have one variable solved for, so we just go for it. So this is number 1, this is number 2. So what I'm going to do is I'm going to plug y equals 7x minus 5 into equation number 2. Okay? So we're going to get 3x minus 2 times 7x minus 5 equals 16. So in the equation here, you have a y, and instead of y, you put what it equals to, okay? Which is 7x minus 5. Is this clear?
Yeah.
And so now we solve. All right, so what is this? That's 3x minus 14x plus 10 equals 16. Clear in parentheses. Now remember, always simplify as much as you can before you start moving stuff around. So that would be negative 11x plus 10 equals 16. And now we finish solving for x, so we just move the 10 over, subtracting. So we get negative 11x equals 6, and then divide. And negative 6 over 11. Are you okay with this so far? Okay. Does this look like? No, those numbers are different than before, right? I remember 6 over 11, but this time it is x. Okay, so now to find y, what you can do is you go ahead, now that you know x, remember that here we took one of the equation and we solved for y. In fact, it was already solved for. All you have to do is plug in your x value in here and you're gonna get your y, okay? And now you have to be able to add this, to subtract the fractions, okay? That's the only thing that this method will require you in this case. So now we're gonna plug x equals negative 6 over 11 into number 1, or into this expression, which happens to be the same thing as number 1. So we get that y equals 7 times negative 6 over 11 minus 5. Okay, so now remember here, okay, yes, you can do that and then solve it like an equation. But here we are really just evaluating, so don't run away. Let's compute it. Okay, let's compute it. So what is this? This is negative 42 over 11, right? 7 times 6 minus 5. Now the negative here, I'm going to put it in the 42. Okay. So how do we subtract fractions? And the same way that we subtract is the same way that we add. The idea is that when the denominators are the same, remember here there is a 1. When the denominators are the same, it's easy. Just combine the top, okay? And you keep the same denominator. Now, what do you do when denominators are different? Well, you make them the same. How? By finding the LCD, and then you multiply each fraction by a suitable number, okay? So at the bottom becomes the same. Let's see, what's the LCD here? 11. So that means a 1 and 11 down here. Okay, this one already has an 11, so we don't touch it. Now, this one we need an 11, so what do I need to multiply this by? 11, but if you multiply the bottom, you also need to multiply the top, otherwise you're changing the whole problem. So I'm going to do times 11, but I also do times 11 on top. Do you understand this? So what do we obtain then? Let me rewrite what we have. We have then negative 55 over 11, right? Instead of a 5, we write a 55 over 11. Now the denominators are the same, we can nicely combine. So what will be the result? Negative 97 over 11. Okay?
Wouldn't it have been easier to just multiply everything by 11 from the beginning?
Say that again?
Wouldn't it have been easier when you were solving for y to just multiply everything from 11?
Yeah, but then you need to solve an equation rather than just evaluate something. You see, you multiply by 11, you have an 11 here, then you have to, it's the same thing. So if you're comfortable with that, yes, because you can treat this as an equation. Multiply by 11, then the 11 will go over here. You will have 55 in here, right? You will get basically this line with an 11 here and no fraction. That's what you're going to get.
Sounds good to me.
Combine and solve. However you want. Okay. Questions? So what's this? Let's write the solution set. So the solution set is a point, and it's a point negative 11, negative 6 over 11, comma, negative 97 over 11.